Hello, everyone, and welcome to Mrs. English Learning Studio.
Yes, welcome in, everyone.
And before we get started, please make sure to subscribe, like, and share this deep dive.
It really helps us out.
It absolutely does. And if you are listening to us right now, I really want to take a second to speak directly to you.
Because today's topic is a big one.
It is. Whether you are currently, in the trenches of learning a new spoken language, like English.
Which is hard enough on its own.
Exactly. Or maybe you are trying to wrap your head around a computer programming language, like Python, for example.
Right.
Being a beginner in either of those can feel incredibly overwhelming.
Oh, it's exhausting.
It's a very specific type of cognitive exhaustion, I think. You are constantly faced with entirely new vocabularies, strange structural rules, and just...
Those frustrating plateaus.
Yes, those plateaus where absolutely nothing seems to make sense.
I remember those well.
We all do. Now, conventional wisdom tells us that when you have two massive, complex mountains to climb, you tackle them one at a time.
You don't try to climb two mountains at once.
You do not try to scale both simultaneously. That just sounds like a recipe for disaster. But, and this is the core of our deep dive today, what if I told you that conventional wisdom is wrong here?
It's a bold claim.
It is. What if doing both at the exact same time actually makes the entire process significantly easier?
I mean, it sounds completely counterintuitive, doesn't it?
It really does.
As a learner, you would naturally assume that taking on two monumental, distinct tasks would simply double the difficulty.
Well, just guarantee burnout.
Exactly.
Yeah.
But the materials we are diving into today suggest the exact opposite.
We are looking at a deeply insightful document today.
Yes, it's titled Learning English in Python.pdf.
And the central premise of this text is just, it's brilliant in its reframing.
It proposes that learning English and learning Python are not mutually exclusive pursuits.
They aren't just separate boxes in your brain.
In fact, they aren't even independent tasks at all.
Yeah.
When you strip away the surface-level differences, the fact that one is spoken and one is typed into a terminal.
Right.
When you look at their foundation, their deep logical roots, they share a striking, almost undeniable similarity.
And that shared foundation is our mission for today's deep dive.
We really want to highlight that.
We are going to explore the internal logical connections between English and Python. Our goal is to help you, the listener, achieve what the source document calls a 1 + 1 is greater than 2 effect.
A synergistic effect.
Yes. We want to show you how studying one actively accelerates your mastery of the other.
And we know this can sound intimidating.
Oh, for sure. Which is why, because we are dealing with two potentially intimidating subjects, we're going to take this nice and slow.
Deliberate and clear.
A very deliberate, clear pace.
Yeah.
We're going to walk through every concept step by step, exploring the philosophy and the practical application.
So you absolutely do not need to be a grammar expert to follow along.
No, not at all. Nor do you need to be a computer scientist.
We're breaking it all down.
Okay, let's unpack this. Starting with the very first core idea from our text, which is the underlying logic of both systems.
Specifically focusing on syntax and precision.
Right. Now, syntax is one of those words that immediately intimidates a lot of people.
Probably because it sounds so academic.
It does. It sounds like a college textbook.
But it simply means structure.
Just structure.
That's it. It is the agreed-upon set of rules that governs how we put individual pieces of information together.
So that they actually make sense.
Exactly. So they make sense to the person or the machine receiving them.
Let's look at the absolute foundation of an English sentence, then.
The document points out that basic declarative English relies on a very specific, rigid sequence.
Subject, followed by verb, followed by object.
We usually abbreviate this as SVO.
Right. So if I say a simple sentence for our beginners out there, let's use the student reads the book.
A classic example.
The student is our subject, the active entity, the one doing the action. Reads is the verb, the action itself, the energy of the sentence, you could say.
And the book is the object.
The target receiving that action. Subject, verb, object, SVO.
It is a very linear, logical progression of thought.
Exactly. It moves from the actor through the action to the receiver.
Right.
Now, let's look across the aisle at Python.
The programming language.
Yes. When you examine the fundamental structure of a basic operation in Python, it is almost completely identical to that English SVO structure.
Really? Completely identical?
Fundamentally, yes. In Python, you have a variable followed by an operator or a function followed by data.
Variable operator data.
Right. If we translate your English sentence into Python logic, the parallel is seamless.
Walk us through that parallel, slowly, for the listeners.
Sure, the variable is like your subject. It's the primary entity or the container you are working with.
Okay, so the student in our example is the variable.
Yes. Then the operator or the function is your verb.
The reads. Exactly. It is the specific command telling the computer what action to perform.
Got it.
And finally, the data is your object.
The book.
The book. It's the raw information being acted upon.
It is.
Both systems, human English and computer Python, demand that you organize your thoughts in a rigorous sequential order.
I think that sequential order is the crucial takeaway here.
It's non-negotiable.
Right. In English, you can't just throw vocabulary words into the air in any random sequence and expect someone to understand your intent.
You just confuse people.
If I say, book the read student, it's not communication, it's just noise.
Complete gibberish.
And Python is the exact same way. If you don't place the pieces in the right order, the computer simply throws an error.
It refuses to guess your intention.
It won't even try. But here is where I want to push back a little bit.
Okay, go ahead.
Because while they both have structure, Python is completely rigid. It's a machine.
Yes.
Whereas English, well, human language is messy.
Very messy.
We use slang. We drop subjects completely sometimes. We imply things without saying them.
We do.
So how does the source text reconcile the strictness of a machine with the messy flexibility of human speech?
That is a phenomenal question, and it actually leads right into how the source material describes Python's specific design philosophy.
Okay, what does it say?
The text refers to Python as executable pseudocode.
Executable pseudocode. Let's break that down for our beginners listening.
Yes, pseudocode is a term programmers use when they're sketching out a plan for their software.
Like a rough draft.
Exactly. Instead of writing actual technical compiling code, they write out the logic using plain, everyday human language.
Like saying, if the user clicks this button, load the next page, instead of writing the hard technical jargon.
Yes, it's an architectural rough draft.
Right.
So by calling Python executable pseudocode, the text is highlighting a very deliberate choice by Python's creators.
They made a conscious decision.
They specifically designed the language to read, flow, and logically structure itself as closely to natural English as possible.
That's amazing.
They wanted a language where the strictness of the machine was masked by the familiar flow of human thought.
That is fascinating. So they purposefully built a bridge between human logic and machine logic.
A very sturdy bridge.
And what does that mean for you, the beginner listening right now?
It means the conversion cost is low.
Exactly. The conversion cost in your brain is drastically lowered. When you are trying to execute a command, you don't have to translate your human desire into some bizarre alien mathematical formula.
You don't have to think like a machine.
You just write it out in a structured way that feels like slightly formalized, highly precise English.
Which brings us to the second part of this underlying logic.
Yes, the precision of the logic chain.
Let's look at how we navigate logic in everyday English first.
Okay.
We use specific words to dictate the logical direction and flow of a sentence. In grammar, we deal with clauses.
Right, clauses.
And we rely heavily on words like if, when, and because.
Those transition words.
Think of these words as traffic signals on a conversational highway.
I really like that traffic signal analogy.
It works perfectly. If I tell you because it is raining, I will take an umbrella. The word because establishes a strict, undeniable logical relationship.
A relationship between the state of the weather and your action with the umbrella.
Precisely. In spoken English, those signals guide the listener through your thought process.
They tell me where you're going.
And in Python, we utilize the exact same signals, but they are categorized as control flows.
Control flows.
Yes. We're talking about words like if, while, and for.
But in programming, as our source text is quick to point out, these aren't just transition words used to make a paragraph sound more eloquent.
No, not at all.
They are the hard, unforgiving execution of logic.
What's fascinating here is the contrast between how we use those words as humans versus how we use them with machines.
Tell me more about that contrast.
In human conversation, we often rely heavily on what the text calls fuzzy thinking.
Fuzzy thinking.
Yes, we use body language, our tone of voice, shared cultural context.
We make a lot of assumptions.
Exactly. We use all of that to convey meaning. Even if our grammar is fractured or our logic is slightly flawed, a human listener will probably still figure out what we mean.
Right. If I mix up my words but point at a glass of water, you know I'm thirsty.
But a computer will not.
The computer has no intuition.
None. The core benefit highlighted in our text is that writing Python forces you entirely out of that fuzzy thinking.
It forces you to be explicit. But wait, if human language naturally leans toward being a bit fuzzy and reliant on context, isn't forcing yourself into Python's strictness going against the grain of natural communication?
It might feel like it at first. It can feel very rigid, but it is actually an incredibly powerful refinement tool.
A refinement tool for your brain.
Think of it like a training gym for your brain's organizational skills.
Okay, I like that.
Writing code forces you to construct an unbreakable logic chain. You have to clearly, explicitly define the if, the when, and the because.
Without relying on a listener to just guess what you mean.
Exactly. By practicing this hard, explicit logic in Python, you are actively training your brain to think more logically and structurally when you formulate English.
It bleeds over.
It does. You start to automatically recognize the structural framework of your own thoughts before you even speak them out loud.
I want to make sure we really emphasize that for you, the listener.
It's a key point.
Because if you are someone who struggles with organizing your thoughts, maybe you find yourself rambling or losing your point when trying to speak English in a meeting or a classroom, writing a little bit of code can actually act as a cognitive structural brace.
It really holds your thoughts together.
It teaches you how to map out a premise, a condition, and a conclusion clearly. It is a phenomenal cross-training exercise.
And that cross-training effect becomes even more apparent and practically useful when we look at the vocabulary itself.
Which leads us to the shared keywords between the two languages, the second major section of our deep dive.
The shared vocabulary.
I think this is where a lot of beginners have a major misconception.
Now, so
Well, when people who have never programmed before imagine computer code, they often picture scenes from sci-fi movies.
oh, like the Matrix?
Exactly, just cascading screens of green numbers, chaotic symbols, and totally indecipherable jargon.
It looks like math homework from another planet.
Right. But Python fundamentally rejects that aesthetic.
Completely.
It doesn't rely on obscure hieroglyphic symbols for its core commands. It relies on basic, everyday English words.
The source document provides a very clear, concrete list of these shared keywords.
Let's hear them.
Listen to the simplicity of these words. If, else, try, except, while, return, class.
I mean, those are incredibly basic.
Every single one of these is a fundamental English word that you would learn very early in your language studies.
There is no confusing computer jargon masking the intent there.
None. Python took these basic English words and simply gave them absolute, strict definitions within its operational system.
So the overlap is very clear on paper. But how does simply seeing the same words on a screen actually help the listener learn them better in spoken English?
If we connect this to the bigger picture of cognitive learning, the psychological benefit is immense.
Break that down for us.
It comes down to building deep muscle memory.
Muscle memory.
Yes. When you are programming a project in Python, you are going to type the word if thousands of times.
True.
You're going to type the word while over and over and over again. The crucial difference is that you aren't just passively reading these words on a flashcard.
Hoping to just memorize a dictionary definition for a quiz.
Exactly. You are actively, physically utilizing them as tools to build a functioning system.
You're putting them to work.
You are associating the physical typing of the word with a specific, undeniable logical action that produces a visible result right there on your screen.
That distinction between passive reading and active tool use is huge.
It changes how the brain stores the information.
You are internalizing the exact logical meaning of that word through repeated execution. And how does that specifically apply to our listeners' English studies?
Think about the word accept.
Okay, let's use that as an example.
Imagine you spend an afternoon building a small Python program. And you use the word accept repeatedly to handle errors.
Meaning you tell the computer, do this normal task, except if this specific error happens, then do this instead.
Yes. By doing that physically, repeatedly, you fundamentally, structurally understand the concept of an exception.
It's hardwired into you now.
So later that week when you are having a conversation in English or maybe you're writing an essay and you need to use the word accept,
You don't have to pause and mentally translate it from your native language.
so don't hesitate.
It feels significantly more natural. You use it with complete confidence because you've practically lived inside that word's core logic for an afternoon.
Exactly. It bridges that frustrating gap between passive memorization, knowing what a word means on paper, and active comprehension, knowing how to wield the word effectively in reality.
Knowing how to actually use the tool.
Tools that you use frequently and successfully become extensions of yourself.
I love that phrase, extensions of yourself.
Your brain stops seeing it as foreign vocabulary and starts seeing it as a reliable mechanism for getting a point across.
Now, here's where it gets really interesting.
Yes, let's get to the practical side.
The source material doesn't just leave us with these fascinating philosophical and psychological connections.
It gives us real tools.
It actually provides 3 concrete, highly practical examples where Python programming is used to solve real-world English learning problems.
This is where the rubber meets the road.
We are going to walk through the logic of each of these examples slowly. We want you to see exactly how this 1 + 1 is greater than 2 effect plays out in practice.
I think these examples are crucial because they move the conversation from theory to immediate utility.
Right. So let's look at the first scenario from the text.
The vocabulary analyzer.
Yes. Anyone who has ever studied a language knows the nightmare of trying to figure out which vocabulary words are actually worth memorizing.
It's overwhelming.
You read an article, there are 50 words you don't know, and you just sit there wondering, should I memorize all of these?
And the answer is usually no.
Right. What you really want to know is which words appear the most often. You want to know the word frequency.
Because you want to focus your energy on the highest value words.
Exactly. But manually counting words on a page with a highlighter and a tally sheet.
Recognizing.
It's agonizing and incredibly inefficient.
But this is where our first practical application comes in. Building a vocabulary analyzer.
Instead of doing the manual labor, the text shows how we can use Python to build a small script.
A script that instantly analyzes a block of English text and figures out the frequency of every single word for us.
Instantly. Okay, let's step through the logic of how the script actually works.
And we won't get bogged down in the exact character-by-character syntax.
Right. Keeping it high level and logical. Imagine a typical sentence you might be studying from a textbook.
The text gives us a raw string of data to start with.
It's the sentence. Learning Python is like learning a new language. Both wreck, and it trails off.
The text cuts off there, but that string of letters is our raw material.
That's our raw data. If we feed that into our Python script, what is the very first logical step the computer takes? Let's take this slow.
The first thing to understand is that a computer is entirely literal.
It has no common sense.
Yeah, exactly. It does not possess human intuition. So, the first logical step the code takes is to standardize the data.
Standardize it how?
By converting the entire block of text into lowercase letters.
Wait, why is that necessary? To a human, a capital L and a lowercase l are the exact same letter, just used differently depending on where it sits in a sentence.
To a human, yes, they mean the same thing. But to a computer's memory bank, a capital L in the word learning at the beginning of a sentence and a lowercase l in the word learning in the middle of a sentence might as well be completely different letters in the alphabet.
Because they have different digital values in the code.
Yes. If we do not actively force them all to be lowercase, the computer will count capital learning and lowercase learning as 2 entirely separate, unrelated vocabulary words.
Which completely ruins our frequency data.
It corrupts the whole analysis.
Ah, okay. That makes perfect sense. We have to strip away the human formatting to get to the raw data.
Step 1, lowercase everything.
So once everything is uniformly lowercase, what is the next hurdle? What stops the computer from tripping over things like commas or periods?
That is the exact next step in the logic. The script utilizes a specific replace function.
A replace function.
Yes. It systematically hunts down punctuation marks and strips them out of the text.
Again, because of strict precision.
Exactly. Think about it. If we leave a period attached to the end of a word like language, with a period, the computer logs that as a distinct entity.
It sees language period as a different word than language without a period.
Yes. It doesn't know what a period is. It just sees a character attached to a string. So we clean the text until we're left with nothing but pure, unpunctuated letters and spaces.
Just clean words separated by spaces.
Finally, the code uses a split function.
What does that do?
This function looks at the blank spaces between the letters and uses those spaces as cutting points.
It chops the long, continuous sentence up
into a neat, separated list of individual words.
So just to recap the logic flow for everyone listening.
Please do.
We took a messy, human-formatted sentence. We forced it to be all lowercase to avoid duplication.
Okay.
We stripped out the punctuation to avoid confusion,
Yeah.
and we chopped it at the spaces to create an isolated list of words.
The text is now fully prepped.
Now we actually need to count them, and the source text explains that we do this using a specific Python concept called a dictionary.
A dictionary, yes.
Let's explain that.
The concept of a Python dictionary is beautifully intuitive because it maps almost perfectly to how a real-world physical dictionary works.
Oh, really? It's that direct.
It is. In a physical book dictionary, you look up a word, which in programming terms we call the key.
The key.
Yes. And next to that word, you find the definition, which we call the value, attached to that key.
So it's always paired up. A key and a value.
Exactly. In Python, a dictionary is simply a way to store data in these linked key-value pairs.
So for our vocabulary analyzer script, what are the keys and what are the values?
In this scenario, the key will be the English vocabulary word itself. For example, the word language.
Okay, and the value?
The value permanently attached to that key won't be a definition. In this case, it will be a number.
A number representing how many times that word has appeared in our text.
Exactly, a frequency count.
Let's explore how the code actually populates that dictionary then. The text describes using a loop.
Yes, a for loop.
It essentially tells the computer, look at our chopped up list of words, pick up the first word, do a specific action, then pick up the second word, do the exact same action, and repeat this cycle relentlessly until there are no words left in the list.
That is a perfect description of a loop.
Yeah.
And inside that loop, the specific action it performs is very clever.
Walk us through it.
For every word it picks up, it checks the dictionary and asks a logical question. Do I already have this word listed as a key?
Okay.
If it does not exist yet, it adds the word to the dictionary and sets its value, its count to 1.
Because it's the first time it's seen it.
Right. But if it checks the dictionary and sees that the word is already there,
It recognizes it.
it simply takes the current value, let's say it's currently sitting at 3, and adds 1 to it, making it 4.
And it executes this logical decision tree for thousands of words in a matter of milliseconds.
The speed is incredible.
That is incredible, but let's bring this back to the listener.
The practical application.
Why is this specific exercise highlighted in our source text? What is the profound dual benefit here for someone doing this deep dive with us?
Well, from the perspective of learning Python, you are getting essential, hands-on practice with one of the most fundamental data structures in computer science.
The dictionary.
Yes, the dictionary. You are actively learning how to sanitize messy data and how to use loops to automate tedious processes.
That's the programming win.
But from the perspective of an English learner, you have just architected a highly customized, incredibly potent study guide.
That is the real magic of this.
It changes how you study.
Instead of relying on a generic top 100 English words list from the internet.
Which is usually boring and irrelevant to your life.
Exactly. You can take an article you actually want to read, maybe a news piece about your specific industry, or a chapter from a book you love. You run it through this simple script you wrote yourself.
And instantly possess a list of the exact vocabulary words you need to understand that specific text.
Ranked by how often they appear.
You are utilizing your coding practice to surgically optimize your language learning efforts.
It is a perfect synergy. The effort you put into understanding the code directly rewards and accelerates your English comprehension.
It's that 1 + 1 is greater than 2 effect in action.
Now, building on that idea of utilizing logic, let's look at the second practical example provided in our source material.
The grammar logic simulator.
I love this one because it tackles a very common friction point in language learning.
Grammar is a huge hurdle.
Counting words is one thing, but for many people, the biggest hurdle in English is grammar, specifically conditional judgments.
The if-then-else scenarios.
Yes. For our beginners, conditional clauses in English are sentences that express a specific condition and the resulting consequence.
Like, if you study hard, then you will pass the test.
Exactly. The scenario presented in our text is using Python to logically simulate the idea. If you stick to practicing, you will make progress.
Let's unpack the logical setup of the code provided for this scenario.
Slowly, step by step.
The text shows us defining a Python function. To visualize this, think of a function as a miniature factory on your computer.
A miniature factory. Okay.
You feed raw materials into the receiving door of this factory. The machinery inside does some specific processing, and it hands you a finished product out the back door.
The raw material we are feeding into this particular factor is a piece of data representing hours practiced.
Yes. We call that the parameter.
So we are simply giving the computer a number that represents how many hours our hypothetical listener has dedicated to practicing their English this week.
Correct. Now, inside this factory, we have programmed 3 strict conditional rules.
These represent our if-then-else logic.
Exactly. The first rule the factory checks is, are the hours practiced greater than or equal to 10?
That's a solid week of practice.
It is. If that specific condition is met, the factory is programmed to output a consequence. In this case, it returns the encouraging English sentence. You have made significant progress.
That's a great positive reinforcement consequence.
It is.
But human behavior is a spectrum. What if they practiced, but they only managed 5 hours?
They didn't hit the 10-hour mark.
Right, but they didn't do nothing. How does the logic handle that gray area?
That is where the second logical rule engages. It utilizes a keyword in Python called elif.
Elif. How do you spell that? E-L-I?
Exactly. Which is simply a shorthand contraction for else.
F.
This is how we chain multiple conditions together to handle nuance.
Ah, okay.
The rule explicitly states, if the first condition failed, check this one. Are the hours practiced greater than 0?
Meaning they put in some effort.
Right. If this condition is met, it returns a different sentence. Keep going. You are on the right track.
And I assume the logic needs a way to handle the absolute worst-case scenario.
The 0-hour week.
What if life got in the way and they put in 0 hours?
Every solid logic chain needs a safety net.
It does.
That triggers the final rule, utilizing the keyword else.
Just plain else.
Yes. The else statement acts as the ultimate catch-all. It basically says, if absolutely none of the previous specific conditions were true, execute this default action.
So what's the default action in our script?
In our script, the default consequence for 0 hours returns the sentence. Consistency is the key to success.
A gentle reminder to get back to work.
Exactly.
So the text then walks through the execution.
Let's run the factory.
We decide to feed the number 12 into our factory.
Okay, 12 hours.
The machinery checks the first rule. Since 12 is indeed greater than 10, it immediately triggers that first condition, skips the rest of the checks, and prints out our success message.
You have made significant progress.
It seems like a very simple exercise.
It is very simple code.
Why does the source text place so much value on it then?
What is crucial to understand here is the cognitive translation that occurs when you build this.
Why are we doing this?
By physically typing out this rigid logical structure, the if, the elif, the else, you are cementing your grasp of how conditional clauses operate in real-world communication.
You are actively, consciously building a decision tree.
Yes.
I see what you mean. When you are forced to teach a literal-minded machine how to understand an if statement, you absolutely guarantee that you deeply understand the mechanics of it yourself.
You can't fake it with the computer.
It completely strips away any of the vagueness we rely on in human speech. You see the strict boundaries of the logic. If condition A is met, B happens. If it falls short, C happens.
This raises an important point about fluency.
Tell me about that.
Mastering this rigid conditional structure in Python makes constructing complex, nuanced conditional sentences in English feel like second nature.
Because you've built the framework.
You understand the architecture of the thought before you even select the vocabulary words. You are, in essence, practicing writing code with your mouth.
Writing code with your mouth. That is a fantastic way to conceptualize it.
It really is.
It really highlights how structured and systematic language actually is underneath the surface.
We forget that when we're just chatting.
And this idea of building architecture leads us beautifully into the final and definitely the most advanced practical example from the source text.
It's automated vocabulary list.
This is where we step up the complexity, but the payoff is substantial.
It is. This example introduces a Python concept called a class.
A class.
Yes, which is the foundation of something known as object-oriented programming.
Okay, object-oriented programming, or OOP.
OP, yeah.
That is a term that makes a lot of beginners immediately want to close the textbook and walk away.
It sounds incredibly abstract and intimidating.
It does. We need to take this slowly. The scenario the text presents is using this OOP concept to build a highly personalized, automated digital word bank.
Right.
How does the text make this approachable for someone who isn't a computer scientist?
The text uses a very intuitive approach by leaning on a real-world analogy.
Let's hear the analogy.
Think of a Python class as a blueprint.
A blueprint.
If you are a construction crew about to build a house, you don't just show up to an empty lot and start blindly nailing boards together.
That would be a disaster.
You draft a blueprint first. Now, the blueprint itself isn't a house you can live in.
It's just a piece of paper.
Exactly. It is simply a master document that dictates exactly what every house built from it must contain. It mandates walls, a roof, a specific number of doors.
Okay, so a class is a blueprint. But in this scenario, we obviously aren't building a physical house.
No,
We are trying to build a digital representation of an English vocabulary word.
precisely. The source text walks through the creation of a class simply named Word, with a capital W.
This is our master blueprint.
Yes, it dictates that every single time we create a new word entry in our digital program, it is absolutely required to have specific pieces of information permanently attached to it.
It mandates the structure of the word.
It achieves this mandate by using a special initialization function inside the blueprint.
An initialization function. I always like to explain that initialization function as the actual construction crew.
Oh, that's a good way to put it.
You hand them the blueprint, and they are the ones who actually build the object based on those instructions.
That's a perfect way to visualize it. The construction crew, the initialization function, takes in the raw materials you provide.
And for our vocabulary word, what are the raw materials?
It requires two specific raw materials: a term, which is the actual spelling of the word, and a definition.
Okay, a term and a definition.
It then uses a special keyword to bind those materials to the specific object being created.
It attaches them permanently.
It essentially stamps the object saying, store this specific string of letters as my term, and store this specific sentence as my definition.
So the blueprint ensures every single digital word we create will permanently hold its own term and definition.
Exactly.
Is there anything else included in this blueprint? Can it do anything else?
Yes. A class doesn't just store passive data.
Yeah.
It can also contain actions.
Actions.
The blueprint in our text includes a function called display.
Display.
This defines a specific behavior the object is capable of performing.
So what does display do?
When you command the object to execute its display function, it takes its internally stored term. It takes its internally stored definition. The things the construction crew gave it. Exactly. It takes those, formats them nicely with some dividing lines or aesthetic spacing, and prints them out cleanly onto the user screen.
All right, so we have established the blueprint. We know what a word object should look like and what it can do.
We have the plan.
Now, the text shows us how to actually construct one of these objects.
We instantiate it.
It creates a variable. Let's call it W1 for word 1.
Okay, W1.
And it essentially tells the system, hey, use our word blueprint. Here is the term I want. Synthesize. And here's the definition I want. To combine different ideas or things.
You provide the raw materials.
And instantly, the computer packs both of those pieces of text into a single cohesive digital object stored inside W1.
Exactly. You have instantiated an object.
And to prove it works, the final step in the text is commanding that specific object, W1, to perform its programmed behavior.
We tell it to run its display function.
And it flawlessly prints out the formatted text. Word. Synthesize meaning. To combine different ideas or things.
It runs perfectly.
Okay, so we've walked through the logic of object-oriented programming.
Which is a huge accomplishment for a beginner.
It really is. But let's bring it back down to earth for a second. What is the dual benefit here for the listener sitting at home trying to learn English?
The benefits operate on two distinct levels.
First level.
On the technical programming side, you are gaining hands-on experience with object-oriented programming.
Oh.
Yes. This isn't a beginner gimmick. This is a foundational concept used in almost all modern professional software development.
You are learning real engineering skills.
You are learning how to architect complex, reusable, and organized data structures.
And on the language learning side?
The benefit is extreme personalization and ownership.
Ownership. I like that.
You are no longer just passively scribbling vocabulary words in a paper notebook that you might lose in a week.
Or using a generic flashcard app created by someone else that doesn't fit your needs.
Exactly. You are literally architecting your own customized, automated digital vocabulary database from the ground up.
You own the entire infrastructure of your learning process.
And because you built the blueprint, you can endlessly upgrade it.
How so?
Once you understand this logic, you could easily expand the word class blueprint later. You could mandate that every word must also include an example sentence, or a list of synonyms, or even an audio file of the pronunciation.
You are utilizing your Python skills to engineer your own perfect, tailored English study environment.
Exactly.
So what does this all mean?
We've covered a lot of ground.
We have journeyed through the theoretical logic of subjects and variables. We have examined the shared keywords and the psychology of muscle memory.
We have meticulously walked through 3 highly practical coding examples that solve real learning friction.
How do we synthesize all of this information into a core, actionable philosophy for our listeners?
The ultimate synthesis of our source text, the grand takeaway, can be distilled down to one commanding directive.
What is it?
Do not learn in isolation.
Do not learn in isolation.
The traditional educational method of siloing your knowledge, studying English grammar for an hour, closing those books completely, and then opening a totally different book to study Python logic for an hour, it is fundamentally inefficient.
It ignores the massive overlap in how your brain processes structural information.
It does.
By keeping them separated in your mind, you are leaving so much potential leverage on the table.
You truly are. The text heavily emphasizes the concept of a bidirectional feedback loop.
Let's explore that loop.
When you sit down at your keyboard and write a block of Python code, you need to realize that you are actively utilizing and reinforcing English logic.
Because Python is executable pseudocode.
Exactly. You are relentlessly practicing the rigid linear structure of subject, verb, and object. You are enforcing the logical boundaries and consequences of conditional clauses.
You are putting your brain's organizational muscles under tension, making them stronger.
And that feedback loop actively flows in the other direction too.
Tell me about the reverse flow.
When you are reading English technical documentation, or even just reading a well-structured English novel, you are secretly improving your brain's ability to parse, comprehend, and anticipate code.
Because you are observing how sentences flow logically.
Right. How variables or characters interact with actions and consequences.
The source material explicitly highlights this bidirectional promotion, especially when it comes to vocabulary and naming conventions.
Oh, naming conventions are huge in programming.
By actively expanding your English vocabulary, you inherently make your Python code significantly more readable and professional.
A major aspect of writing good, sustainable code is choosing descriptive names for your variables.
Right. If your English vocabulary is limited, you might lazily name a variable X or data 1.
And that tells a future programmer or yourself in 6 months absolutely nothing about what that data actually represents.
It's useless. But if your English is strong and precise, you name that variable calculate total score or highest frequency word.
Strong English naturally creates what we call self-documenting code.
And conversely, by routinely writing Python code, you train your brain to make your spoken and written English more structured, logical, and ruthlessly organized.
You naturally begin to stop rambling.
You start speaking with intentional purpose, instinctively ensuring that every sentence you utter has a clear logical flow and a definitive conclusion.
Just like a well-written script that compiles without errors.
It is a truly beautiful symbiosis. You are attacking the universal problem of communication from 2 completely different angles.
One angle is deeply human, full of nuance and cultural context.
The other angle is entirely mechanical, requiring absolute precision and rigid structure.
By dedicating yourself to mastering both simultaneously, you achieve a level of communicative clarity and cognitive flexibility that is incredibly difficult to reach by studying either discipline in isolation.
It's all about breaking down the artificial barriers we build in our own minds regarding what subjects are allowed to overlap.
Language, at its core, is simply a tool for expressing internal logic.
Whether you are expressing that logic to a friend sitting across a coffee table, or you are expressing it to a silicon chip sitting in a server farm across the world, the fundamental underlying machinery in your brain is doing the exact same work.
Exactly.
As we conclude our deep dive into this remarkable source text, I want to hand it over to you for a final thought.
I want to leave you with a final, somewhat philosophical thought to ponder.
I love a good philosophical thought.
We have discussed at length how Python was specifically and intentionally designed as executable pseudocode to perfectly mirror the logic and flow of natural English.
Right. It was built by humans to reflect how humans already think and speak.
But consider the reverse implication of that relationship.
Okay.
If a highly complex, flawlessly logical programming machine can be built directly upon the foundation of everyday English grammar,
Yes.
does learning this specific coding language reveal that the way we speak English is actually just an ancient, verbal form of programming? Are we simply executing biological code on each other every single time we engage in a conversation?
Oh, man, that is a mind-bending thought to leave off on.
It changes how you look at a conversation, doesn't it?
I absolutely love that perspective. Are we all just walking biological computers running ancient verbal software to alter each other's states of mind?
Something to think about.
You will definitely have to chew on that concept while you review your vocabulary lists and debug your Python scripts tonight.
Best of luck with your studying, everyone.
Thank you so much for tuning in to Ms. English Learning Studio. Remember to subscribe, like, and share this deep dive with anyone who loves learning. See you next time.